Today we're going to be talking about LLaMA files. So what is a LLaMA file? So a LLaMA file that lets you run or distribute a large language model with a single file. And since ChatGPT became popular and large language model became a mainstream thing, a lot of people have been trying to run a good quality language model on their local computer, so they don't have to give their data to corporations like OpenAI, Anthropic. They can just run the language model on their own systems, on their own hardware. And it's been a year or two, and we have been slowly gaining on the closed source models. And I think we are at a point where the open source models are giving the closed source a run for their money. And I've been exploring various ways to run or to use language models on your own machine. And I have found LlamaFile really fascinating for that, which we will be talking about the why. So first, let's talk about how you can run language models, small or large, on your own machine these days. So a bunch of options you have, you might have heard about, is LLaMA, softwares like LLaMA or LM Studio. So you download these and you download the GGUF files for the large language models uh, from Hugging Face, and these softwares let you inference them. Uh, you can even create a remote server with them. Another popular one is LM Studio, which I'm sure most of you guys have heard of it. If you have not, there's a ton of videos on YouTube that can help you learn about it, how to run a language model using this on your machine. The only limitation I found with these softwares is if you're building your own project and you would like to inference the language model in your custom coding project, you would need one of these softwares to run the remote server for it to be inferenced in the code. So this limitation I did not want to have, and this is with both the softwares because they're third-party softwares, right? So Llama files really help you in this regard because it's a single file, single executable file if you're on Windows that you can just run with a single click if you just want to chat with the language model, or you can also have this file create a remote server in the background that if you can Dockerize it, put it in a Docker container, you can have your own little language model server running locally, and then you can inference it within your own custom coding projects. And why I chose this time to create this video about LlamaFile, it's been out for a while, but I think we are at a point where with models like Llama 3.2, which came out a couple of weeks ago, I've noticed even though the size is comparatively smaller, it's 1 billion and 3 billion parameter models, and we have much capable models if you want to go for 7 billion or 8 billion parameter models like the Llama 3.1 or the newer ones from Alibaba, the Quen series of models are really capable. But if you don't have that capability, then the 3 billion model I have found to be really capable. And today we're going to be experimenting with this model, learn how to use the Llama file, how to create your own Llama file, and in the end, we will learn how to create a remote server with the help of Llama file that you can then inference and use in your own custom projects. So let's begin. So the first thing we would like to do, guys, is just show you, if you do not know much about Llama file, I would recommend you to go to this GitHub repository, read up on it, and just understand what it is. It's built up on the Cosmopolitan library in C. So check out their GitHub repository. I would recommend first. There are pre-made Llama files available for language models, as well as uh, one thing I forgot to mention that is pretty amazing is you can also use vision models with Llama files. So you can talk about images with the help of models like Lava 1.5. And it works pretty well for the Q4 quantization. You'd be surprised. But yeah, I would recommend to give it a try. But anyway, before that, I will I will show you guys how to run a Llama file. So first we will go on Hugging Face. You can download from here as well, but these are limited number of selections. So I would recommend to go on Hugging Face. Just type Llama file, go to models, and as you can see, there's just tons of models right here that other creators have created and uploaded them on here for us to use. So the latest one that has come out is, of course, the 3.2 LLaMA, a 3 billion parameter model. So to use that, open up the link, go to Files. Now, in this particular link, we have these three versions: F16, BF16, and Q6 quantization. So, guys, this in a nutshell is how much the weights have been reduced for the size to reduce the size. It There's a little bit of sacrifice in quality, but it's not so much. So if you don't have a powerful machine, I would suggest go for the Q6. So you click on the download here, and the download will start. So once you have that file downloaded, as I have right here, it will look something like this with a .llama file extension. Now to run this file, if you're on Windows, it's very simple. You just rename it with a .exe extension at the end. It will ask you if you're sure, say yes. So this converts it into an executable file. And to run this, all you have to do, guys, is double click it. It will take a little bit time. It might ask you for permission at this point. Just give it the permissions to for the firewall if it asks, and then it will open up the command prompt like that. And we'll just go through some of these parameters. It will map everything, and then it should open a window in the browser, which we should see in a second. So just give it a few seconds. Usually take 5 to 10 seconds in this step. There you go. And there you go, guys. So you'll have one of these interfaces open up uh, where you can chat with this model now. There are a bunch of parameters: temperature, predictions, top K, top P, minimum P, and you can also edit or play around with the system prompt if you would like to. I'm gonna leave it as it is right now, and I'm just gonna have a conversation with it just for the sake of showing you guys. So right now, it is running on the CPU currently, all of the model. We're getting 8.55 tokens per second, so it's not bad, it's usable. So yeah, it's as simple as that, guys. With a single click, you can run the language model locally and you can talk to it. So I found this to be the easiest way without any software. Uh, and later in the video, we will also discuss how you can use this. Because right now we have a remote server created at this endpoint, and we can use it in our code if we would like to. And I'm going to be showing you how later in the video, so stick around. The next thing we're going to do is I will be showing you how you can create your own LLaMA files. So to create your own LLaMA file, uh, what you will need is a GGUF model file. So if you're not familiar, these are the model files we usually download in LM Studio or LLaMA. It's with a GGUF extension, as you can see here. These are all the models I have downloaded locally. So you will need So you can go on Hugging Face again. You can search GGUF, right? And yeah, you will get a result of these models right here. Most, I should say, or all of the models, you should be able to find the GGUF file on Hugging Face. And I will show you how to create a llama file from that because you can't find llama files for all the models on Hugging Face. So you might come across where you will need to create one for yourself. So let's pick someone. So let's pick an uncensored one. So this is a bit too big. I want to show it. Yeah, let's pick 3.2 instruct uncensored. So someone made an uncensored version of Llama 3.2 3 billion. It's in GGUF format. So let's use this, create a Llama file for this model. So we're going to go to files and versions. We will download, I prefer the Q8 one because it gives you a correct balance, in my opinion, between quality and the speed of inference. So just click on download here and yeah. The next thing you will need to do is you would go to the Llama file GitHub repository, and over here you will see the releases, the latest one. So you will click on it. So as you can see, the latest version is this. So you will scroll down now, and right here in assets, we should see this zip file. It's 472 megabytes. Just click on it. That will download it. So once we have this downloaded, so it will look something like this. It's a compressed zip file. So what you will do is extract it, extract. There you have it. What I like to do, I would just, for the sake of it, I renamed it to LlamaFile. So you can do the same if you want to, or you can leave it right like this. You would go inside the folder where you see the bin and the share folder. And here what I did is the GGUF version we downloaded earlier, I just pasted it right here. So now we have this kind of setup. I have everything ready, and I will now convert my GGUF file, which is this, to a LLaMA file. So what we need to do for that is, it's pretty simple. Let me show you the steps. Uh, so you would need to execute these in bash because these are Linux commands. So you would open your git bash terminal right here. Alright, so what you're gonna do now is navigate uh, to this location right here where we have our GGUF model as well, and we have our bin folder. So you can use the command for your location. It's pretty simple. So this is it for my location right here. CD space whatever the location is up to this file. Enter. After that is a little bit of a crucial step. What we will be doing is, you see this bin directory right here. So we will be adding this to the system path so we can run the LlamaFile convert command, which will convert this GGUF format to a LLaMA file. So if you're familiar with adding this to path manually, you can do that. You can find it on YouTube how to do that, but I will just give you a simple code that you can execute in your bash terminal, and that should temporarily add this in our path, in the system's path. So why we do this, guys, is so our systems know where to find the llama file dash convert when it needs to run it in the next step. to convert the file from GGUF to LlamaFile format. Uh, anyway, so getting back to it, here is the command. So this will temporarily add this bin location to the system's path. Enter. There you go. So now we will do the final command. So it will be this command would convert this file, we have the GGUF file, to the LLaMA file. Now the reason I have this file here in this location is so we don't have to change location here. For some of you watching the video, you might be novice and you might get stuck here, changing the location again. You might not be familiar with Bash. So for the sake of simplicity, I move this file here. Otherwise, you can have it anywhere. Anyway, getting back to it now, our command is going to be so we'll use this command. We will tell it to use the LlamaFile.convert and space and then the name of your model in GGUF format, which is this, and enter. So you will see it's converting this. It will run for a few seconds, and there you go, success. So you may now run the LLama file. And over here, you can see the LLama file has been created. So that's it. It's pretty simple. And now we can minimize this. And to run it, as we saw before, is pretty simple. In Windows especially, you can just make it executable, exe, yes, and you double click. It will just run through some processes in the command prompt, and then it should open up the local server in the browser. It usually takes about 5 to 10 seconds, as we saw before. And there you go, guys. We have the model we just converted right here. So let's talk to it. Hi. See if it works. Yes, it is working. Uh, so it's uncensored one, so it should have some censorship removed. So write a poem about. Right. Let's try some uncensored. You can see it's working. So we just created this llama file right here. I showed you how to do it, and you can just use it very easily, very simply. And there you go. Close. Now what I want to show you is, as you might have noticed, the speed was workable, but we can do better, especially if your local computer has a graphic card, a GPU. You can use that to inference this model a lot faster. Now to do that, let me show you. Uh, you will first need to download a CUDA toolkit. So just type CUDA toolkit. You will go right here, download now. So if you're on Windows, select this architecture. I'm on Windows 11, exe local, and click on this, and you should have the installer right here. Then you should install it. Just follow the instructions. Just a disclaimer, you might need to add something to the system path again for this, which it will prompt you once the installer is finished. So, guys, you will have to learn to do that if you want to play around with these tools. So, ask ChatGPT or watch some videos on YouTube. But yeah, follow the whole process. I'm not going to do it now because I already have it installed. But yeah, add it to your path, and you should have. Uh, if you don't have CUDA installed, you will have to do this. Otherwise, if you do have it, you don't need to go through this process. And let me show you how you can run it with CUDA now. So we closed our language model right here. All right, so to run it with a graphic card, you would, your command would look something like this. So here, guys, it's nothing but a bunch of parameters that I'm giving it. So I'm reducing the context size to 2048 tokens, which you don't need to do if you have a capable system. So usually what you do is you give this uh, dash ngl and you do 999 and you run it like that. But what I found, guys, sometimes you get an error with this command, like I have been getting here, because for some reason it just doesn't detect my NVIDIA graphics card. So if that doesn't work for you, I found a solution to this. So we will keep NGL35 just for the sake of testing. And what worked for me is adding this GPU tag in the end, and then I tell it it's NVIDIA. Uh, I'm sorry, it should be double hyphen. So let me just do it again. GPU NVIDIA, and there you go. Let's see. So there you go. It found my GPU now, as you can see here, and we have it running. Ta-da! So that works for me. Some people can just get it up and running with the NGL 999 at the end, but that doesn't work for me. So if it doesn't, try this out. And there you have it running. Now let's test the speed. Do we have improvement in the speed? Okay. So, hi, look at that. Write me a poem. So as you can see, if you didn't notice before, the speed is about double of what it used to be, and it depends totally on what kind of GPU you have. As you can see, we are getting 15.75 tokens per second. Without the GPU, we were getting around 7 to 8 tokens per second, so it is doubled. And I have a pretty modest GPU. If you have a better one, you can do much, much better. So there you go, guys. Isn't this incredible? I find it pretty incredible. And what's the best thing about this is it's not just about this interface. So what you would be able to do is what we're going to do next is use this server in our coding projects when we are prototyping or just we want to use a local large language model, which is I think is pretty capable. So I'm going to show you how we can leverage this server and how you can also not have this browser open up uh, when you want to just run it in server mode. So let's explore server mode for the LlamaFile now. Alright guys, so I will close everything now. So the server we are gonna close as well. Okay. And I will show you how to run this LlamaFile in the server mode. Then you can which you can leverage in your own code while prototyping. You wanna use a local model. You don't want to use third-party softwares like LM Studio. And I think it would be pretty good for production as well because if you Dockerize that, you can just have your own server, little server running inside a Docker container, and you can leverage that pretty easily. All right, so let's see now. So we will open our git bash. Mm, and I'm sorry, there's a lot of things going on here. Alright guys, so let's see how we can run the server mode. So again, I have my bash terminal open. I will just navigate to the location where my llama file is. There you go. And now what you want to do guys is, so the same command, just we're just going to alter the command a little bit. So there you go. That's the name of our llama file, space dash dash server no browser. There you go. So what this will do is it will just run the remote server. It would not open the UI in the browser like we were using before to talk to the model, but the model will be available at the endpoint. Let's see how it goes. There you go. Enter. Again, 5 to 10 seconds. I ran it without the GPU this time, just for the sake of simplicity. And there you go. So you can see here, Llama server listening at this. So this is our local host URL where the server is running. Now, what's the use of this is you can build your own custom code and you can use the LLM at this endpoint, and you can build whatever custom workflow, custom inference pipelines you want to build with it. There's just the possibilities are endless. And so let me show you, just let me verify if it's running or not. So we're just going to go to IDE. I like Visual Code. Just create a new file, a Python file, and we're just going to save it. Server lf LlamaFile.py. Okay, and I will just ask ChatGPT to write me a basic code to inference this server, so we can see and verify if it's working or not. So let me go back into ChatGPT. So I just asked it to write a simple Python script to query this server. So as you can see, this is our server, and we just add the completion into it. So how this server works, guys? It mimics the OpenAI endpoints. So the same way you will run an OpenAI server, it mimics that. So uh, you would just have to use this endpoint, which our language model is running at. And I will just copy this code. I'll go to VS Code right here, paste, save. Okay. So there, the URL we have here, we are passing these headers with the prompt, just explain quantum physics in simple term. We are giving it some parameters, for example, how much it should produce, just 128 tokens. Temperature, top K, top P, you can play around with those. So now let's see if it works. Uh, I'm just gonna maximize this right here. All right. Okay. So let's navigate to our folder now. It's in Python. Okay. I'm just going to navigate to where my file is. It's right here. So right here. We're just going to do cd, and for some reason, there you go. And then we will run this file, which is called server lf.py. So it's running in the background. Let's see in our bash how it looks like. There you go. My bad. There you go. So you can see it's running. Because we did not use the GPU, it might take a little while to, there you go. And this is the response we got. So we asked the question, explain the quantum physics in simple terms, and this is the answer we got right here. You can extract it by modifying the code. This was just to verify that we have our server running. So there you go. Server running in the background. You can build a pipeline of this LLM inference, get the results as you want. You can also build a retrieval augmented generation component to it, give it your own data, build your own custom project based on it. Pretty cool, I think. And you're not dependent on any third-party software. You are running it all on your own computer without any software. This can be uh, Dockerized into a container, and you're not dependent on anything. This is pretty cool, which I find. And most people who are into open source and who are into uh, using local large language models, who want to own their own AI and not use proprietary models like OpenAI or Anthropic, it's only going to get better. Uh, Within the next 3-4 months, I believe we should have models that are very much comparable to GPT 4.0 and smaller models, which you will be able to run like this locally, build your own projects, and the possibilities are endless. So, yeah, just wanted to share it with you. I find this really useful in building my own projects. So, if you find it useful, like, comment, and so if you want to see more of me building and experimenting with the local open source AI, feel free to come back and check what I'm up to. And thank you for watching this video. Hope you enjoyed it, got some value out of it, and have fun building with AI. See you guys.